This is my last video for how to solve a system of equations with what is called the elimination method. And you're going to notice that we're going to need to first multiply our functions by a number to create opposite signs for the coefficients in front of the letter that you have there. And so you might need to do just kind of a little bit of thinking here about how you want to do your canceling. And for example, this is what I mean. To get my 5x and my 3x to cancel, they have to first be opposite signs, which these are not, and they need to be the same coefficient. Now, if I have a 5 and a 3, what I would have to do would be multiply my top equation by 3 and my bottom equation by 5, and one of those would need to be negative for these to cancel out. That's how I'd have to use multiplication. But now let me look at my y's. 2y would cancel with a negative 2. So instead of having to multiply both equations by a number, I'm going to multiply only my second equation by negative 2 because a negative 2 for the y will cancel with a positive 2 for the y in the first function versus having to multiply a couple numbers here for the x's to cancel. I tend to take the easier route, just a little bit less work, but then there's less steps for you to make a mistake. All right, so here we go. The bottom equation, if we multiply by negative 2, will get us negative 6x if I distribute that negative 2, minus 2y, and then equal negative 4. If I copy down the first function that I have here right underneath and align my x terms, align my y terms, and align my number terms, and I put my plus sign out front, I know I'm going to get some canceling here, which is what we wanted for elimination. That's why we call it elimination method. My y's are going to cancel out here. And what I'm going to have now, if I add these together, negative 6x plus 5x will give me negative x. Negative 4 plus 5 will give me 1. If I divide by negative 1, my solution for x is going to get me negative 1. So that's half of my answer. Now what I'm going to do is pick one of the functions, and I'm going to sub x equals negative 1 into one of those functions. I'm just going to pick the top equation. 5x, or 5 times, if I sub in for my x here, negative 1, plus the 2y is equal to 5. So that was my first function, but now I'm substituting in my x value of negative 1. You're going to see here I'm going to get negative 5 plus 2y is equal to 5. If I add the 5 over to this side, I'm going to have 2y is equal to 10. And if I divide by 2, my solution for y is going to be the number 5. So if I put those together in a point, an ordered pair, the ordered pair would be negative 1, 5. And that's the solution where those two lines cross. All right, let's try another one. And then maybe you'll be bold enough, you can hit pause on the video and you can try the last one on your own. I see here a negative 1x. I see a positive 2x. Those are not going to cancel out. A negative 5y and a negative 7y. Well, I think I can get this first function here to cancel out with a positive 2 if I just multiply by 2. Because if I have negative x times 2, that's going to be negative 2x, and a negative 2 is going to cancel out with that positive 2. So here's going to be my function when I multiply through with a 2. Negative 2x minus 10y, because negative 5 times 2 is negative 10. And 30 times 2 is going to give me 60. So just make sure you distribute that 2 to every part. I'd say that would be it where I see a silly mistake, is just not distributing correctly. And then if you have the wrong equation, then you're not going to get the right solution because you are solving with the wrong equation. So distribute for every single term. All right, now the bottom equation, don't change it at all. Minus 7y here, and then 25. If I combine these functions together, I'm going to see my x's cancel out because one was a positive and one was a negative. So this is what we want here. Now, when I add my functions together, negative 10 minus 7y is going to give me negative 17y. 60 and 25 is going to give me 85. If I divide by negative 17, I'm going to get the value for y. Okay, let's see here. 85 divided by negative 17. I get an answer of negative 5. Now substitute y back into either equation. So I'm going to pick the top function, negative x minus 5y equal to 30, and I'm going to sub in negative 5 here. Negative x minus 5 times a y value that we just solved for of negative 5 equal to 30. This is going to be, when I simplify here, negative 5 times negative 5 is positive 25. And if I solve for my x, I want to get my x isolated. So I'm going to subtract that 25 to the other side of the equal sign. And now I'm going to have negative x equals 5. I'm close. I'm almost there. I just don't want the negative on this side, so I'm going to move it over to that side. I get an answer of negative 5. So here's my ordered pair. It's going to be an x value of negative 5. Oh, and a y value, also negative 5. So there's our solution. There's our point. All right, here's the last one, 6.3. Here we go. I see a negative 4 for x, a positive 3 for x. Those are not going to cancel. A 2 and a 5 for my y. Again, those are not going to cancel. But what I do see is negative here and positive here for the x's. I see those signs are already opposite. I like that. So I'm going to choose to eliminate my x's. And the first multiple that 4 and 3 have in common would be the number 12. So I'm going to turn both of these functions into 12s for my x's by multiplying both functions by a number. So this time I just have to do both. Negative 4 times a 3 is going to get me the 12 that I need. And for the bottom function, 3 times 4 is going to get me the 12 that I need for my x's to cancel. So watch, here's my first function when I multiply every number by 3. I'm going to get negative 12x plus 2 times 3 are 6 for the y, and 5 times 3 are 15 here at the end. And now here's my second function. If I multiply by 4, here I'll use a different color just kind of for emphasis here. 4 times 3 is going to give me positive 12x. 4 times 5 is going to get me 20 for the y value. And 4 times 6 is going to be 24 for the constant at the end. I see now that my x's finally have that same coefficient that we need to be able to cancel the terms out. And I'm going to just kind of highlight that. These are going to cancel out, which is why we call this the elimination method. And now let's see what we got when we combine our terms. 6y's and 20y's makes 26 for the y here. And that will equal 15 and 24, or 39. Okay, now I'm going to divide by 26. I have a feeling I'm going to get a fraction here. But you know what? Sometimes it happens. All right, let's see. 39 divided by 26. Yes, I have a fraction. It's 1.5. I'm actually going to use my fraction button to put this into fraction form because I don't want to use a decimal. So let's see here. My fraction button. 39, my ABC fraction button, 26, is 1.5, which we already knew, 1.5. Second, and my fraction button will convert that to an improper for me. So reduced would be 3/2. All right, now we're going to plug in 3/2. It's a fraction, but you know, we can still do this. Pick one of your functions and we're going to plug in 3/2 for the y value. I'm going to use the top function. Negative 4x plus 2y is equal to 5. And now I'm going to sub in my 3/2 for the y here. All right, negative 4x plus 2 times 3/2. Oh, that's actually going to work out nice because our halves are going to cancel. Equal to 5. All right, let's see. Let's zoom in just a hair here for you. So negative 4 times x plus, now 2 divided by 2 is going to cancel out. So you're really just going to have 3 here, which is not so bad. Hey, that actually works out quite nice. Now to solve for my x, I'm going to subtract that 3 over. So I get my numbers over here on the right side. So I have x is equal to the number, let's see here. Oh, I got 2. Now divide by negative 4. Oh, look, another fraction. 2 divided by 4, that's a half, and I see that negative sign there, so I'm going to write negative. So here's my solution. I actually had 2 fractions, negative 1/2 and positive 3/2. Way to go. That was a tough one.